Okay, I'm going to do a quick set of solutions for this assignment. So the first question is list all 8 possible roots of this polynomial. We're going to use the remainder theorem to determine what possible roots there are, the factors of 3 over the factors of 2. This is going to be plus or minus 3 and 1 over plus or minus 2 and 1. So then that gives us 3 over 2, 3 over 1. I'm just going to put 3 for that. And then 1 over 2 and 1, and then all these but negative. So negative 3 over 2, negative 3, negative 1 half, and negative 1. Those are all my possible roots. So now I'm going to plug these in until I figure out one that equals 0. That's the remainder theorem, right? If I just plug these into this, if I get it equal to 0, then that means it's a factor. So I'm going to plug these in until I get 1, and I get... So I'm going to show you a little trick for checking all these points so you don't have to keep plugging them in. It's okay if you use this on a quiz if you tell me why it works. So you have to cite the remainder theorem and say I plugged in to see which ones equaled 0. But you can just plug in the function and then make a table referencing this function. The f of x1 is very important so that it plugs it into the function, this part right here. And then you just type all the roots in, and it'll tell you which ones equal 0. So 1 half equals 0, negative 1 equals 0, and negative 3 equals 0, so I can use whichever one of those I want to write my to do my long division. So I think x plus 1 will be the easiest one, so I'm going to do that. So after dividing, this is what I get, 2x squared plus 5x minus 3. So now I have a semi-factored function. I need to factor this using the box and diamond method or just looking at it. So I'm going to do that. So I want to note this part because this is a little trickier one to use box and diamond method with. You can kind of cheat. You can look at the factors in your Desmos that worked, right? So we know 1 half is the other one and negative 3. So that would be x plus 3 and x minus 1 half. It's not exactly those, though, because you have the 2 here. But it's going to be 2x. You know you have the x, right? So you can do x plus 3 here. And then this is going to be 2x minus 1. So then you have negative 1 times 3 is 3. X times negative 1 is negative x. 2x times 3 is 6x. 6x minus x is 5x, so it works. So then, so now we factored it. So we have x plus 1 times 2x minus 1 times x plus 3. Another tip you can use, to use Desmos to factor this a little easier. You can go here and say, well, I know all 3 roots, so I can write it as x plus 1 times x minus 1 half times x plus 3. That's not the same function because this has a 2 in front and you need something to give you a 2x squared, but this is the same function. Because if you multiply the 2 times the x minus 1 half, you get 2x minus 1, and then it's the same function. So either one of these work. One of them you don't need to do long division for if you can figure out how to use that coefficient correctly. And you're confident with that. So this is the factored form, either one of these, and then the roots would be x. I'm just going to put them as points. So I'm going to put negative 1, 0, 1 half, 0, and negative 3, 0. And so that's how you do those. I'm just going to put the answers for the rest of them because it's the same process. So with this second one, once again, I can see all 3 of my roots in the table. It's going to be 3, 1, and negative 5. With this one, there's no coefficient, so I can actually just skip the long division and write it out as... So it's going to be x minus 3 times x minus 1 times x plus 5. And my roots will be 3, 1, and negative 5. Next one, we'll do the same thing. So my factors are plus or minus 6, 3, 2, and 1. So I can put those into Desmos. So this is interesting because it only tells me one factor, which means there's only one real root. So this one's going to have some imaginary roots. you don't have to deal with that. You can leave the second term as a quadratic, but we are going to have to do long division for this. So our one root is x equals 1, so we'll divide by x minus 1. So after dividing, we get x minus 1 times x squared plus 6. And just looking at x squared plus 6, I know it is not factorable. So that is our factored form. And then our roots are going to be just 1, 0. Or sorry. Yeah, 1, 0. Sorry, that's right. Okay, now let's go down and look at these end behaviors. So this is just, all you need to do is reference that chart, and then it's pretty straightforward. So looking at 1, we've got the two things you look at when doing end behavior is the leading coefficient and then the degree of the polynomial. So this one has a positive leading coefficient and an even degree. So if we look at our notes for end behavior, we have a positive leading coefficient and an even degree, so we're looking at 2 arrows pointing upward. So that's going to be this one, D. So 1 is D, and I can just say like positive leading coefficient, even degree. And then let's see, number 2 is negative leading coefficient and odd degree. So now we're looking in the second column, negative leading coefficient, odd degree. So we're going to have the arrow on the left's up, the arrow on the right's down. So left is up, right's down, so that's C. And it's because it is a negative leading coefficient and an odd degree. Number 3 is negative leading coefficient, even degree. So looking at our notes, we're looking at negative and even. So that's going to be this one right here, 2 arrows, or sorry, negative and even, 2 arrows pointing down. So then going back to 2 arrows pointing down, that's B. And that one is B because it's negative leading coefficient and even degree. And so then the last one must be A, and then that's going to be because it's a positive leading coefficient and an odd degree. And then the last one, we're going to just basically look at those boxes again. This one has a negative leading coefficient and an odd degree. So that's going to be this one right here, negative and odd. So then we're going to say as x approaches infinity, y approaches negative infinity, and as x approaches negative infinity, y approaches infinity. So basically they're just the opposites. And then for the last one, we've got a positive and an even. So positive, even, that's this one right here. So we've got y goes to infinity in both situations. And that's that assignment.